Jai Hind to all of you. I am Dr. Gaurav Saxena. Today I discuss the fundamental of electronics engineering having a code of BEC 101. So today topics is very important topic is Zener Diode and voltage multiplier circuit. So what is the meaning of Zener Diode and how we build the Zener Diode, and what is the difference between the normal PN junction diode and Zener Diode, and what is the application of Zener Diode as a voltage regulation. So I discuss here, and some important numerical which I have to be discussed here. And voltage multiplier, so we know the what is the application of very important application of PN junction diode is voltage multiplier. So that means that if I having a voltage of 5 volt and any circuit you want a voltage of 10 volt and 15 volt or 20 volt, so we use a voltage multiplier by using the PN junction diode. So what is the meaning of Zener diode? So Zener diode is a special purpose of diode having a reliable allow current to flow in the backward directions. So the Zener diodes applications as a voltage regulation in the reverse bias manner. So that means the having a minimum to maximum Zener current, they have to be allowed at a fixed voltage. So this type of Zener diode is called the Zener diode. So what is the application of Zener diode? So Zener diode, what is the characteristics of Zener diode? So Zener diode characteristics in the forward direction as well as the reverse direction. So this is the forward bias region and this is the reverse bias region. So in this forward bias region, this is the diode voltage and this is the diode current which has to be flow here, or we can say if Zener diode, the symbol of Zener diode is this, and if we, this is a P terminal, this is N terminal, if we depicted a P terminal is to be connected to the positive half of the positive supply of the battery, and N terminal is to be connected to the negative half of the supply, and this is a variable voltage, or we can say if we calculate the voltage across this Zener diode is VD. So, and how much current flow in that particular circuit is ID. So we draw a this circuit and VI characteristic, and we see that the cut-in voltage is greater than the normal PN junction diode, which one is 0.73. So this is the cut-in voltage. So we can say that Zener diode works as a normal PN junction diode having a cut-in voltage greater than the silicon and the germanium. But in the case of the reverse bias manner, so we can say if we connected the P type terminal into the negative of the supply and N type terminal is to be connected to the positive of the supply, so we see that no current flow. If we increase this voltage, so that means if we increase this bias voltage, so a heavy current flow in the reverse bias manner. So such current is called the Zener current in breakdown region. We see that in this region we have to see that in the reverse bias manner of the Zener diode, a heavy current flow, but the voltage should be same. So that means they allows the minimum to the maximum Zener current. So this is the minimum Zener current to the maximum Zener current. So we see that if the current increases but the Zener voltage is to be constant, so that means this type of phenomena is to be used in the Zener diode application, just like a Zener diode works as a voltage regulation. So this is the Zener diode. What is the regulation parameter? So if this is a Zener diode having a Zener voltage Vz, and this is the load, so we want a fixed voltage Vz appear at the load terminal, and this is the input resistance, and this is the Vi, this is the input voltage. And if so how the load current is to be varied by two manners. That means if we increase or decrease the input voltage, so such type of regulation is called the line regulation. So in this manner, if we increase or decrease the input voltage, so the load current in the RL direction, in the RL, which one is increase or decrease. So according to that, IL into RL drop is to be decreased and increased. So voltage is to be not fixed. So this type of if we fixed this output voltage at Vz voltage, so this type of regulation is called the line regulation. So that means in the line regulation, if the input voltage to be varied but the output is to be fixed by using the Zener diode as a voltage regulator in the reverse bias manner, so such type of regulation is called the line regulation. But in the load regulation, if Vi is fixed, and load resistance to be varied, so that means that if the load resistance is to be high or low, so that means they fluctuate the load current, that means the IL into RL drop is to be varied. So that type of voltage regulation we have to be fixed by the Zener diode, and this type of regulation is called the load regulation. So by using the Zener diode, we fix the load regulation as well as the line regulation. So some example I have to be taken. So this is a very simple example. So we have to be put it for the Zener diode in the network, determine the what is the load voltage across the resistance R, and IZ, this is the IZ is the Zener current, and PZ is the Zener power which has to be dissipated by this Zener diode. And repeat part A, this part is to be repeated with RL is equal to 3 kilo ohm. So first of all, this question is to be solved by 1.2 kilo ohm resistance, and this question is to be repeated if the load resistance is to be 3 kilo ohm. That means the 1.2 kilo ohm. So we calculate the VL, VR, IZ and PZ, and then we calculate the this all the term line voltage, VR voltage across the resistance, and the Zener current and the PZ with 3 kilo ohm resistance. So what is the first step? So first step is you have to just open this Zener diode. So if we open the Zener diode, so we calculate this open circuit voltage by using the potential divided theorem. So how much voltage to be appear at the VOC? We have to be see that VOC is equal to the RL upon RL plus R into VI. So this potential open circuit voltage to be determined by the voltage divided theorem RL upon RL plus R into VI. So that means this voltage is to be 8.73. So if we see that this open circuit voltage across the Zener diode, or we can say we appear a Zener diode voltage is 8.73, which one is VOC, and the Zener voltage is 10 volt. We see that VOC is less than VZ, so that means 8.73 voltage to be here. That means Zener current should be 0, so that means the IZ should be 0. So IZ should be 0, that means the IZ should be 0, that means the how much voltage to be appear at the VR. So that means VR is here. So this, because we know that in the parallel the voltage to be same, so that means the VOC or V12, which one is terminal, which one is equal to the V34, or we can say VL, which one is equal to 8.73 volt. So this one is potential drop is here 8.73 volt, and VI is 16 volt. So by using the charge conservation law, summation E is equal to 0. So that means summation E is equal to summation IR. That means the 16, which one is equal to the 8.73 plus I into R, or I into R, which voltage? I into R is the VR. So this VR voltage, how we find it? VR is equal to 16 minus 18.73. So what is the voltage? 7.27 volt. So we easily calculate the how much voltage is to be appear when the load resistance is 1.2 kilo ohm and the across the voltage open circuit voltage is less than VZ. So that means the IZ should be 0, because this circuit you have to see that if we draw a VI characteristics of Zener diode, so 8.73 volt is here. So that means at that point the Zener current should be 0, so IZ should be 0. So that means the how much Zener potential or Zener power we have to be calculated by VZ into IZ. So VZ, which is given that, and the IZ should be 0, so that means the 0 watt. So if we load resistance is 1.2 kilo ohm, so that means the Zener power is 0 watt, and the voltage across the load is 8.73, and the voltage across the R, which one is 7.27, and the Zener current should be 0 ampere. So we easily calculate this question. And if second part is, if the load resistance to be vary 1.2 kilo ohm to 3 kilo ohm, so that in this question we easily calculate the what is the open circuit voltage. So open circuit voltage we have to be calculated by the potential divider theorem. So what is the potential divider theorem? So we easily calculate VOC is equal to 3 kilo ohm upon 3 plus 1 kilo ohm into 16. So that means that this voltage is 12 volt. So that means the 12 volt is to be appear. So that means Zener diode work here. So that means that this load voltage, which one is equal to the VZ, or VZ is 10 volt. So what is the current flow in that particular load, which one is IL is equal to VL upon RL. So VL is, which one is equal to VZ, VL is equal to VZ, that means the 10 upon 3 kilo ohm. So that means the 3.33 milliampere current is to be flow in the load current, which is fixed because the Zener diode works as a voltage regulator circuit. So then how much voltage is to be appear at the VR? So 16 volt is here and 10 volt is here, is to be here. So if we apply a KVL here, so summation E is equal to summation IR. So that means summation IR is equal to, what is the meaning of this? Summation E is equal to -2 plus it to be here. So that means this one is 16 volt minus, because this is the IR resistance loss, because this is VR and this is the plus minus VZ voltage. So this one is VZ voltage, which is equal to 0. 16 minus VR, and VZ is 10 volt. So what is the VR potential? VR potential is equal to 6 volt. So we easily calculate the what is the VR value, which one is 6 volt. So this one is 6 volt, and how much current flow here? So we know that, so I is equal to I into R, which one is equal to 6 volt upon 1 kilo ohm. This one is 6 milliampere. So 6 milliampere is to be flow here, and IL is to be fixed here 3.33, because this circuit acts as a voltage regulator circuit which fixes the voltage of 10 volt. So that means what is the IZ? IZ is equal to IR minus IL. So that means the IR is equal to 6 milliampere minus 3.33 milliampere. So this one is 2.67 milliampere. So the value of IZ is equal to IR minus IL, which one is equal to the 2.67 milliampere. And we find the what is the Zener power. So Zener power is to be calculated by the VZ into IZ. So VZ is the Zener voltage. Zener voltage is 10 volt, and IZ current flow in 2.67 milliampere. So that means which one is equal to 26.7 milliwatt. So this question we easily calculate. If the load resistance is 1.2 kilo ohm and 3 kilo ohm, we see that when load resistance is 1.2 kilo ohm, so this Zener diode does not work, and the Zener current should be 0 and the PZ is equal to 0. But in the case of load resistance is 3 kilo ohm, so that means the Zener current we have to be calculated 2.67 milliampere, and the load voltage to be fixed at the Zener voltage reverse breakdown Zener voltage, which one is 10 volt, and the load current is 3.33 milliampere. We have to be calculated by VZ upon or VL upon RL, and the voltage across the R is we have to be fixed by the KVL. 16 minus 10, which one is 6 volt, and the input current or IR which have to be calculated by 6 upon 1 kilo ohm, which one is 6 milliampere. So 6 milliampere is to be input current, and IL current is to be divided here because this is the parallel circuit. So that means the 6 milliampere current is to be flow here, and 3.33 milliampere is to be fixed current is to be flow in the load current. So how much current flow in the Zener? So that means the 6 milliampere minus 3.33 milliampere, which one is 2.67 milliampere. We have to be calculated very easily. So in this case, if the load is varied and the input is fixed, so this example is to be here. So for the network of determine the range of RL and IL, that will result the VRL being maintained at 10 volt. So that means determine the maximum wattage rating of the diode. So we also calculate the PZ maximum, how much, and you have to be calculated the what is the IL we have to be calculated, and they have to be see that what is the value of RL minimum to maximum, and we see that which is fixed by VRL, and VRL is given that which one is fixed by 10 volt, which is equal to the Zener voltage. So how we calculate this? So that means you easily calculate by using the formula. This we know that Vz is given, so Iz maximum is given, so that means we know that Vz is equal to 10 volt and Iz maximum is equal to 32 milliampere. So Pz maximum, which is equal to the Vz into Iz maximum. So that means Vz is 10 volt, this one is 32 milliampere. So Pz maximum is 32 milliwatt. So first question is to be answered, how much Zener power is to be dissipated by that particular Zener diode. Second one, how much voltage to be appear at this resistance. So this one is plus minus, so this is what is VR. So we apply a KVL in that particular loop. So what is the KVL? KVL is the summation E is equal to summation IR. So we apply a KVL in that particular loop. So that means minus to plus, which one is plus 50 volt, minus what is the voltage drop is that particular resistance, which one is VR. So which have to be calculated, and how much voltage to be dropped here. So this is plus, this is minus, because this Zener diode works as in reverse bias manner as a voltage regulation. So that means this terminal N to be connected to the plus and P is to be connected to the minus. So that means this voltage is, what is the Zener voltage, which one is 10. So we easily calculate VR, which is equal to 40 volt. So that means VR is equal to 40 volt. So that means how much current flow in that particular area? 40 upon 1 kilo ohm, that means 40 milliampere. So we know that 40 milliampere is here and 32 milliampere is to be divided here, because in the question given that the maximum Zener current is 32 milliampere. So 40 milliamperes flow in that particular direction, and that means the 32 milliampere is to be divided into the Zener terminal. So remaining the 40 minus 32, that means 8 milliampere current should be flow in the load resistance, and we know that the load voltage is to be maintained, which one is equal to 10 volt, and the load current, which one is 8 milliampere. So what is the load resistance? So we know that RL maximum, which one is equal to the VL upon IL. So that means VL is equal to 10 volt, IL is equal to 8 milliampere. So 1.25 kilo ohm. So we easily calculate what is the load resistance maximum value, 1.25 kilo ohm. So that means this value is to be here 1.25 kilo ohm. This is the maximum value, and the minimum value, if we choose the minimum value is Iz should be the 0 ampere. So that means 40 milliamperes to be current flow here. That means because no current flow here, so IR, which one is equal to IL. So 40 milliampere current flow here. So what is the IL? IL is equal to 40 milliampere, because Zener current should be 0. So that means RL is equal to VL upon IL. So VL load voltage to be maintained is 10 volt, and the IL, which one is equal to the 40 milliampere. So 40 milliampere, that means the 40 into 10 is power minus 3. So that means 0.25 kilo ohm. So that means the minimum value of that particular resistance is 0.25 kilo ohm. So the resistance value of load resistance lies from 0.25 kilo ohm to the 1.25 kilo ohm. So in the next question, we have to be asked, what is the range of the input voltage for IZ maximum is 60 milliampere, having a Zener voltage should be 20 volt. So in the same manner, we have to be calculated what is the input voltage range which maintain the maximum Zener current is equal to the 60 milliampere. And last one is, what is the application of Zener diode? Application of Zener diode is to be used as a voltage regulator and over voltage protection, because if the line voltage to be increases, so if we use Zener diode as a reverse bias manner or in a voltage regulation, so they provide a fixed voltage or fixed voltage at the load resistance. So the over voltage protection also a very important application of Zener diode. Using a clipping circuit, we have to be use it, and if we use the shift the voltage, so we use a Zener diode. Thank you. Very important book we have to be use for making this presentation, and HS Culsey also very good for electronic instrumentation, George Kennedy, and but the Robert L. Bolstead book is to be the textbook. We have to be covered all the basics of Zener diode. Thank you.